Okay, so before the break, we were talking about data structures, lists, and array is our general go-to term because we don't have arrays in Python on technicality, but most of our data structures have names that we would use in regular English as well. So array doesn't really come with any preconceived notions. Doesn't have any common usage outside of computer programming. So that's our go-to term. Same way we say Google instead of use a search engine, or apply filters on a search engine, or we say TiVo instead of DVR. Those just common terms that take over the thing. So we talked a little bit about it. Those continuing on to a further degree after this course, you will go into that stuff that I was writing on the board, those diagrams and stuff in much greater detail in later classes, see some of the differences for it. For all of us, though, we're going to be using it a lot. So let's go ahead and take a look at the Python syntax now. So I'll open it up on the Windows machine here. And I'll just use Notepad++. Do I need to save either of those? I hope not. I'm not going to save them. So, like we've seen before with Python, we don't have to say what type of data we have. It's a similar thing with our collections of data. We don't have to explicitly state beforehand whether we have a list or a dictionary. When we enter one, the language will figure out what we have. So I'll start with a list. That's probably what we're going to use the most often. That's just the general versatile one. It's the basic one, like an array, only we have those extra little benefits if we can mix our data types, and it's dynamic. We can make it larger or smaller as needed. And we indicate a list in Python by square brackets. We can start with an empty one and add stuff to it. That can often be a good form, because then the same way that I've gone back to a couple times in the examples of building up a string instead of one long string, spread that out over several lines and then just add a little bit to it each line. We can start with an empty list and then fill it up over several lines, and lots of small, simple steps is better for the computer. Complicated steps might make the text file look nicer or shorter, but that doesn't necessarily mean it's better as far as running goes. Computers do better with lots of short, simple instructions instead of big, complicated instructions. So eventually it has to be broken down into simple instructions anyway, because the machine itself only has the ones and zeros to work with. So we can start with an empty one. I'm just going to go ahead and fill this up. Maybe start with a couple numbers, and we'll enter just a comma separated list. A couple numbers there. I'll mix in some words, red, green, blue. Those are good words for string examples, and maybe a Boolean. So mixing a whole bunch of data there, and then I'm going to go ahead and save this so it changes colors. Let's see, where can I save this? The documents, delete, and I'll call this collect.py. Some random name so we can refer to it. And now we can use indexing to refer to this. I believe everybody saw this in SDEV 120, so it's not exactly new here. Just doing the pass on it to reiteration is good for committing things to memory. So we can grab these values and do things with them, like we can do math. So I'll do that first. That's our basic operation on a computer. My list, and then in square brackets, we ask for some index. And in Python, we do start our indexing at 0. So 0 is the first element. 1 is an index of 1 is the second element, index of 2 is the third element. So there's that discrepancy between our cardinal and ordinal numbers. So some languages went ahead and switched it to 1. That way, first, second, and third line up with 1, 2, and 3 nicely, and it makes it easier to think about. Performance-wise, there's not going to be a whole lot of difference. And the difference is going to be in picoseconds, way shorter than anything a human would notice. But sometimes when we mix our languages, like we start using SQL, structured query language from Python, then Python starts indexing at 0 and SQL starts indexing at 1. So we have to take care of that discrepancy. We have to add 1 or subtract 1 to make our indexes line up. Whichever way makes more sense in your mind. It's just to add or subtract 1 operation, so it's not going to make much difference efficiency-wise, which translates to time-wise. So we can ask for any of these. I'll ask for index number 1, which would be our second element, times that MyList collection index number 2. Those both have numbers in them. And then we can print that out. So I'll save that, and I'll just come over to PowerShell and run this. I'll do it with keyboard shortcuts. I like to show those. I think a lot of people are on Windows machines, so I keep PowerShell down in the taskbar there, because then to access the things in the taskbar, you push the Windows key and whichever digit it is, starting at the left. So here on my taskbar, you can see on the screen, Chrome is all the way to the left. So Windows 1 will open Chrome, or the PowerShell I have on Windows 2, and then that opens that thing out of the taskbar. You keep stuff in there. Very, very useful, customizable shortcuts. I'm not sure what that is on Mac. I'm sure there is a similar one on Mac. And on a Chromebook, it's Control-Alt number to get from the taskbar, which is also what it is on Ubuntu. So all our systems have it. I just don't know what that keyboard shortcut is on a Mac. But on a Mac, you have Command Space to open the search bar. That is a very, very quick search thing. But the Windows key and one of the numbers will open things right from the taskbar. And then we can just change the directory, which CD was abbreviated because it was created back in the 70s. When they updated PowerShell, one of the things they did was words are spelled out. So we don't have to remember what it does and how to ask for it. We can just spell it out when we ask for it. So the same set location is the same thing as change CD, change directory, or on a Windows machine, it's actually current directory, because we can ask for the spot we're at that way as well. So we can set location. I'll go into the documents folder and then the delete folder. And yeah, I'll just use the O command. Can't remember it quick enough, so I'll just go with the O command to pull up the list. And there's that Python script. So open the Python interpreter and run collect.py. Or, and most of y'all are probably working in nice IDEs instead of just a text editor and essentially the command prompt, the updated version of the command prompt, the Windows control software. You just probably just hit your run button. It's a whole lot easier that way. We can see that we did math with those numbers. Nothing surprising there. 2 times 3 gives us a 2 in the second end spot and a 3 in our third spot, which are indexes 1 and 2. And we multiply them together, get a number there. We can reassign stuff. So we can say my list index number 1. In other words, we'll change the second thing to a 4. And then I'll do that math again. That'll be enough to see it change. So I'll copy that and run that same instruction again after changing the list. Oops. I guess I need to print it. Helps if we can see it. Although if you're in a nice ADE, you can just check your variable monitor and see that just as well. A watch window or variable explorer or whatever it's called for the particular one you're on. So 4 times 3 gives us 12 now. So we can reassign values in the list. We can also just print the whole list. We can just say print my list. I'm going to print an empty line first, though. We'll print just a few elements out of it, maybe my list index 3, my list index 4, my list index 5. And I'm using the common thing here. Some of that's integer. One of those is an integer, two of them are strings, so that would involve casting. We've seen that a few times. I think everybody's had to, or I feel confident everybody's had to go back and fix that typo a time or two now, where you forgot to cast an integer into a string. You get that message that probably don't even have to read anymore by 4 weeks into Python. And as soon as you see part of that message, you know exactly that you forgot to cast your floating point number to a string before you printed out the price of something. Oh, I guess those were all strings. I could have added those together. So printed those out. We can print out particular individual things. I print the whole list. I'll do that next. Or we can just say print my list with no indexing. Whoops, I have to spell print correctly. The color changing is nice. That is referred to as Lexing. Has to do with like lexicon of a language. You may have heard that about like English in an English class. We call that Lexing, and it comes from a list in the Python programming language. So if I come up here, you can see we get the whole list printed out. And while I'm mentioning that, let's take a look at that list. Where does this color changing come from? How does every software that knows about the Python programming language know how to change colors? Which words to change colors on? How did it know to change colors on print and true, but not on my list? And that's included in the language as a list. So we've talked about this before. The language itself, the interpreter knows our core pieces. The assignment operator, like math operators, selection keywords for selection structure, and there's a short list of things that the interpreter knows, and then those things were used to pre-build some methods and stuff for us. One of those being those words that are going to change colors. So I'll navigate down to where Python's stored here on my machine, which is in hidden folders. So you have to show the hidden folders. And users have to add a local in a folder called programs. The language itself is buried kind of deep in here. Then Spider comes with its own installation, those using Spider. So there's a couple things particular about that IDE that they made the change because they thought it was better than what the language did by default. And usually it is, but it takes slight changes to work with. Like if we want to install more libraries, we have to go through extra steps so we can use pip with Spider, but it's not a big deal. And somewhere down here, it's libraries. So these are just a whole bunch of Python scripts. One of them on here is keyword, which I think is out here at the top. Eyes in keyword. So every one of our languages, all our programming languages have a file somewhere in there written in that language called keywords. And for Linux or Mac users, you'll notice it starts with a shebang. So set up to be cross-platform compatible. Run it right in your bash scripts. And then it goes to a keywords dictionary. So this is how we tell anything built from Unix. They don't have much Unix kernel left in them, but they are still built up from it. The comment for like be quiet, and then the exclamation mark is often just read as bang if you need a quick way to pronounce that, which happens in coding because the exclamation mark often means something. So those who haven't seen that before, that line is called a shebang. And it tells the computer where to look for the interpreter to run this with. If we scroll down, you'll see there's this thing called KW list, which is, and all our languages are going to include this. And it's just a list of words that you probably recognize, at least quite a few of them by this point in Python. Obviously false, none, true, and as we've seen a few of those. With that with thing, the syntax I like for writing files, saw that the other day, like with open some text.txt in read mode as file handler. Break, if we're finished looping, we'll jump out of it. Continue, defines for functions. Finally, goes in error handling, try, return, and a whole bunch of words that are, those are the words the interpreter knows. So they change colors. And then we can add to that list. If we want to handle Lexing, we bring in that list and add to it. Like whenever I write up something to run code, I like to look at variables and include the name, variable names that the programmer is going to add in there to that list of predictive things. Your those predictive boxes, those come from the keyword list as well. That doesn't come from the text editor or the IDE you're working on. That comes from the language. And all we do is it just asks for it. So we can customize that and include our own variables and stuff just by manipulating that list. What else do I have here? Oh, we can check things. So notice I put a Boolean in there. I'm gonna add some white space here because I don't like working at the bottom of the screen. So we can check that. So there's a Boolean there at the end. We'll say if my list index something, which index is that? 0, 1, 2, 3, 4, 5, 6. So I think we saw that we could actually check any of those because nothing in that list is false or 0. So they would all return. They would all count as true. But that one has true explicitly. If my list, then we'll print it's true. Something trivial. But just like we could store a Boolean in a variable and check that. Just keep our data in there and get that. Or we could put the actual condition here. Let me put an else in here. Else print that's a lie. That way we can tell at a glance which one showed up instead of just saying it's false. And we can put the condition in here. So 5 is greater than 3. Will be a true statement. That'll evaluate to true. So the computer will evaluate it before it stores that data. We don't have to go through and do the calculation ahead of time and store that. We can do the calculation right there. And we see that that returns it's true, or we could say 5 greater than 7. And what is stored in there is just false. And I guess the big point there is we don't have to figure out what it is and then put it in the list later. We can just do that when we fill up our list. Oh, one thing I forgot to do is get the link to this. I think it's this in Python. Oh, yep. The length of something. You can tell us all lengths of all sorts of stuff. There's a built-in one. So say print the length of my list. That's a useful thing to have at times. Clear this and oh, I should zoom in on that. Let me zoom in so that's a little bit easier to see. Is that better? You'll see that somewhat better. Sorry, Alex. So we can see there's 7 things in the list. And notice that that's the count, not the index. So back to that start from the beginning, count from the end. I went to point at the other screen here, but I guess the people on the video can't see it. Oh, I'll annotate it. That'll show up on both screens. Because if we go count this, we're going to work. We got 1, 2, 3, 4, 5, 6, 7. So that's indexes 0 through 6. Because we ask for the beginning of the data, but we don't count index 6 until we get all the way over here, all the way at the end of the data. But we ask for the beginning of it. Now, we ask where we start reading it from. And lister dynamics, so we can change that. So it's an annotation thing, and is that gonna work? I need more room than that. Oops. I just wanted to get where I could see both of them. Okay, that would probably work. We can add things to it, and our method for doing that is append. We can append things to our list. Is that what I had in my list? Add or take away first? Oh, yeah, added it. So at this point, I'm going to print a couple line breaks to kind of get down to a better spot. Then I'll print what is currently in the list, and then call that list. And then we use the dot operator, which we'll talk about object-oriented stuff soon. One way to think about it is that list has a bunch of stuff to it, not just those indexes in there. There are other things about the list we can ask for, and the dot operator gives us that. So my list, but we don't want one of the indexes, we want something about the collection itself. And one of those things is like an append method. We call this method called append and add another thing into the list. And then I'll just print my list again, followed by some blank spaces. And spread this out. Save that and come over here and run it. Or if you're in IDE, just kind of print stuff off. And there's a couple ways to remove things. I mentioned earlier when there was a stack drawn on the board, let's talk about that. Our term for taking the top thing off the stack, the last thing put in there, is to pop it off the stack. So that's the go-to way for removing things from a list in Python. So we say my list.pop and print my list again. So I guess I don't need the spaces in between them. I'll get that in a moment. So we can add something there at the end of the list and then pop that thing off. And that's essentially how we create a stack if we need that. We have our data, so we use a append method to load it all into a list and then pop it back up off the list, which doesn't really show up in this class much. The computers have gotten pretty big. There's a lot of RAM there, but we can still use it all up. So we don't want to keep things they're wasting memory if we're done with them. So it's good to get things into memory and back out as soon as we're finished with them. So that's why things like stacks are very useful, because it loads it in when we need it and then dumps it when we're done with it. So it doesn't stick around wasting memory. That stuff I stored up at the beginning, you can see I used it all these lines later. So it's still in there wasting memory even if we don't need it again. So to create a stack, we usually append stuff and then pop it off in that same order. If I go run this again, well, maybe if I clear the screen first and then run it, you can see here's where we appended that on and then we popped it off. So the last thing to go in there is the first thing to come out of it. Last in, first out. And that's essentially how we use a stack, which the standard example of that is the stack of plates after we wash dishes. The last plate to get washed and put in the cabinet is probably the first plate to get used. We also have queues. The odd spelling Q, not CUE like the game of pool. That word where the UE is silent when we read it in English. A queue, and that's like the drive-thru at McDonald's. The first person to place their order is probably going to be the first person to get their order. A first in, first out structure, add a structure. So to do that with append and pop, we kind of need to go the other ways. For those going further with stacks, our standard terminology is to push something onto the stack and then pop it off the stack. And with a queue, our terminology is to pull and, sorry, I suddenly drew a blank on the word. I was there just a second ago. Pull the data and POLL, kind of like an election poll or something, like preparing it to check for the data, and then I'm suddenly drawing a blank on the other one. But we have Google in our modern world, so let me look it up real quick. Probably would have been faster to look it up on the computer that's not on the Zoom call. I didn't think about that. Terms for queue and stack. Pull and yeah, sorry, it just bothered me when that word suddenly slipped out of my mind. Like it was there just a second ago. Oh, this word, on queue, and we usually pronounce that deck. You know, it's a lot of words that standardly pronounced deck. There's another terminology that's used for it, and I don't see it here. It's probably going to come to me later, sorry. It doesn't relate to our stuff here. Add and remove things from stack and queue. That's the basic idea. Stack is last in, first out, and queue is first in, first out. First thing we put there is first thing we get used. So to do that with we can use the pop method as well, and we can pass in an index that we want to remove. We can say my list dot pop, and instead of leaving the parentheses empty, which will be the last element in our list, we could pass in an index, say index number 3. So now when I run this, you can see the first pop. Oh, wait, sorry, I have to print it again. Print my list so we can see what that did. Get that out of there. So you can see the first pop removed that last thing we put in, with no arguments passed in, it's just the last thing. When we passed in an index, it removed index number 3, which is the word red, apparently. So we can take things out of there. And that's another really nice feature. We don't have to keep our data around the whole time. And when we set it up with variables, like that analogy I said, we had to carry everything around the whole time. If we don't need it, we can pull it up. But with the backpack analogy I introduced this with, if we don't need it, we can take it out of the backpack. We don't have to carry it if we don't need it, which is a good thing with to get stuff out of RAM when we're finished with it. So that's usually more stressed in the higher level courses. I just thought I'd go ahead and mention it. What else did I have on list? Okay, that was the ones I had on list. So that's kind of the basic ones to start with. You'd also start with an empty list and then use the append and pop method to move the data in and out as needed. That way you don't have it there burning up RAM the whole time, or just to practice getting used to them. If you need it bigger, append. If you need it smaller, pop. And also extend. I might as well show that. MyList.extend, which is just like append, only we add an entire list. More stuff. It's comma separated between those things, so we're adding more stuff to it. Oh, once again, it helps if I print so we can see the difference there. Then print my list with those changes. Because I guess not the lack of an error message isn't really a good confirmation. You can see it just added the stuff there. It added another list. So we can append a single element at a time, or we can extend our list by an entire another list. Any questions about list? They're very straightforward. You've probably seen them before. Should be fairly intuitive. It's an at this level, use it mostly for organization. Like that intro example where we had the payroll calculator. Categorize those things and have an employee one list that has all of the employee one data, or create a name list and have everybody's name indexed from like what the original variable names were, and then an address list. Whichever form of organization makes more sense to you. Excuse me. Oh, I don't have a drink in here with me. So at home, the virtual calls at home are nice because I don't worry about bringing drinks from my own computers or a good spot to sit in. Oh, okay. So after list, another common data structure is tuples, which are essentially just like a list, only they're immutable. Once we create it, that's what we have. So at the introduction level here, it's a good, maybe think of it as protecting your data. You can't accidentally change it. It can't be accidentally changed. And we define those with parentheses instead of square brackets, but then just a comma separated list in there still. 5, 5, 8, false, just a bunch of data mixed, just like we have with the list. Then I'll just print that out. I'll print a couple blank lines to separate it from the previous stuff. And then I'll just print that out to start with. So you can see it kind of the same thing, it just printed with parentheses instead of the square brackets. But if we want to ask for a particular one, we access it by square brackets. So my tuple index 3 in square brackets, 0, 1, maybe 2, index 2 in square brackets, We run that. Oh, if I spell it correctly, change that to my tuple. And we've seen name errors before. Usually indicates a typo. So you can see square brackets are used to access the same thing, but it may not necessarily go the other way. We saw way up here that we can just give the index from that array and say, well, change that to a 4. The tuples are immutable. We cannot change them. So if we say my tuple 2 equals a 3, we want to change what's in there. When we go to run this, we get an error message. A type error. The tuple does not support assignment. We want to rechange. So if we want to change a tuple, we basically have to make a copy of it. And we have to make a slightly different copy of it, which there are built-in methods to do that. I guess another thing, we saw the dot append. Well, maybe we can add a 3 onto the end then. So instead of reassignment, I'll just try to make it larger. Run this and another error message. This time an attribute error. A tuple has no attribute called append. Again, it's immutable. The IM at the beginning, and big word, but similar to, means can't be changed. Or that other one we saw, if we try to pop an element off the end. Run that, once again, we get an error message. Again, it's an attribute error. Hopefully those 3 examples were kind of enough to see the difference in those error messages as well, right? When we had something that was like a variable, the reassignment, it gave us a type error. And when we tried to use the dot operator and call some methods, some functions, which actually that comes next, doesn't it? Earlier I was saying GUIs carry the next section. So we'll talk about functions before we get to GUIs. But we'll put in parentheses for a function, which we'll talk about next week, is built into that. Those were an attribute error. To kind of help make sense of reading those. Basically, tuples can't be changed. I'm going to write a quick function here to jump ahead because we're going to see this. I'm going to delete this one immediately afterwards because we haven't talked about these, but we can return more than one value. Do stuff. I'm getting ready to delete this. Just wanted to show it while we're talking about tuples here. Because if we return multiple values, notice the form it comes back in. There are parentheses. So when we have a function that returns multiple values, we get those values back in a tuple. So we might need to turn those to a list, which I think it's just list. Let me see if yes. So it's a built-in method. We can just say list and then wrap that tuple or the method sending us a tuple in a list. And then we get back to the thing in square brackets, which you saw we can change that. We can modify that. So remember, if you return multiple values from functions, which we will see on Wednesday or Monday, we're going to talk for a couple of days about functions. It comes back as a tuple. So you might want to cast that to a list, which we haven't talked about functions, so I'm going to delete that and just use the, I'll put that as here for example, because after class I'll ask the comments to send this out. Might be in the morning though. I woke up at 4 o'clock this morning. I still haven't adjusted the time schedule. I usually wake up at 5, so I saw some looks here in the classroom. Computer people are like, what? Awake at 4 o'clock? You mean getting ready for bed at 4 o'clock? I usually wake up at 5, so with the time change last week, that's what my body's used to. It just the clock said something different. But still, that was a long time ago. So it'll probably be 4 o'clock tomorrow morning before I add the comments in here. Email that out. So we can turn my list to a tuple. Why not clear this? Get back to the top of the screen. Run that, and then the tuple becomes a list. So our pop and append and extend and all that stuff that we saw earlier, or simple reassignment, would apply at that point. So, that's where you probably want to use tuples at this level to protect your data. Keep it as a tuple so that you can't accidentally change it, and then have specific spots where it can be changed. That way, have better control over what's going on with it. And that point I made a couple weeks ago, a string is, or go in the Python interpreter. String is hello world. That's a good one to work with. We can index a string, right? We can ask for index 3 of a string and get a letter back. A string is a tuple, and we can't just reassign it. So if we tried to say string index 3 equals a y, we get string does not support item assignments. So this is where that technical definition of array in the languages where we have arrays, that's where we usually use those, because they're immutable. If we want to change it, we have to make a new array. If we want to make it bigger, we have to make a bigger array. I guess we can usually still change arrays, but a string is a tuple in Python. Oh, not clear, exit. Now clear. Do I have anything else about tuples? No, but one more data structure I want to look at. If we look up here how we're accessing this stuff. Well, I'll use the highlighter. So here to grab those numbers, we use index number 1 and index number 2. It's almost a little bit confusing because in this case, remember index number 1 is our second thing, so that's holding the number 2. And index number 2 is holding the number 3. So that adds extra little confusion on there using those numbers. Not really much affiliation at all between red and index number 4. So same thing in tuples, we just use the numbers. It'd be nice to have another way, a more precise way to index these things than just random numbers. Because the computer doesn't know what the numbers are, those are for humans. And they're not very useful for humans either. There's a lot of things that might confuse us. So that's where dictionaries come in. In other languages, some languages, these are called maps. So in Java, we would call this a map. And like PHP, both of those are languages that are essentially just cleaned up C++. We would call this an associative array. I like that term a lot better, associative array. Instead of using numerical indexing, we will use an associative index, something that has meaning compared to what we're storing. So I'm going to use my normal class data, name, age, town. That's a nice, easy one to work with. And these come in key value pairs. And whatever we call it, a dictionary in Python, a map in Java, associative array in PHP, or by far the most popular one, JSON object in JavaScript. The most powerful thing about this sort of data structure is it can leave our program. Everything else we've seen about holding data is stuck to our program, right? If we declare a variable in one script, we can't use that variable in another script. If we create a list that's just like a variable. We can't create a list in one Python script and use it in another one unless we open up that original Python file and read it like a text file. We can't do that. That's where that keyword list thing came from. But my dictionaries, we don't really use that much in Python, but in general, this sort of data structure, because of the way we assign things, the indexing isn't related to how the language assigned a number to it. The indexing is a string that we assigned on it. So we can take that to another language, and then it's still indexed by a string that we assigned on it. And the data would be, as long as the other language can interpret that. So in general, these sort of keyword pair data structures, associative arrays, that's the terminology I like. Mappings, that one kind of makes sense because we can hand a map to somebody else and they can, if they know how to read a map, they can find directions around that map. It's kind of like that. Because instead of a number index, I'll use name for an index. And then I'll just put my own data in here. Name's going to store the value Chris. And then again, a comma separated list. The difference is that we gave it an explicit index to use. And say, don't use index 0, use the string name as an index. And a string is a common thing, so other software could deal with the string just as well. Then an age index and a colon to say whether that's indexing. 43 and town is Clarksville. Oops. And that's like drifting off my screen. There we go. And then some use curly braces to declare those. And if you want to make this clean, this would apply to all of these. There are places we're allowed to put in line feeds. So if we have a comma separated list, we can separate it after the comma without anything extra. So we can bring that down and kind of split this up after each one of our commas to make it look a little bit cleaner. And let's see if I got a indentation error from that anywhere. Okay, no indentation error. Be careful with that because it is Python significant white space. So if you accidentally copied down four spaces, the standard indent in Python, that's going to mean something to the interpreter. So watch for white space when you split it up between lines. But it makes it a little bit easier to read and basically split it up at the commas without anything extra in there. Then we ask for things not by a numerical index. We still ask for an index, and it still gets square brackets when we ask for it. My dictionary, but instead of a number, we gave it a string sort of index, which makes it a lot more meaningful and easy to work with. So now when we print that, you see it printed out the value. So keyword value pairs. The keyword is our index, and then the value is what we're actually storing, the data we want to work with. Very, very nice data structures to work with, especially for organizing and keeping things nice. What all did I have in here? We can print the whole thing. Print my dictionary, like we've seen a couple times, or like all of our data structures. And when it prints out, we get the curly braces to help indicate that we have a dictionary there. The list method would work as well. Actually, wait, that might mess up. Let me check. And we can always try things and see what, make changes, see what happens. Does this work? Does this work in Python? I need parentheses there, not square brackets. Notice what happened when I changed it to a list. it gave the keywords, not the values. So you have to be careful about that. So probably don't want to do that one. What else do I have in here? Oh, we can reassign stuff. I say my dictionary, the age index, reassign that to 21. I'm at that nice age, halfway between the two birthdays of Anna. Turn 21, we can go to bars. And a little while later, we turn 65 and don't have to work anymore. I'm exactly halfway between them. So we can reassign just like we do with an array, and we just have to use that index. Print my dictionary. So I've got a lot of prints here. You can see it just automatically changed the value. If I went to, what's next in here? Add stuff to it, we simply add another key value pair. We don't need a fancy method like append or extend like we had with the arrays. Say, well, I want to add in a fave food. I'll do it in camel case. A fave food index and assign it the value pizza. So now if I print my dictionary, oops, trying to make that a little wider. You can see it added another key value pair. So we don't need anything fancy. We just add, throw it from square brackets, throw in the name of a keyword thing, and then add to it. Which gives us an, that's how we create a blank one. Just start adding stuff to them. Very, very useful. What else do I have in here? Oh, this is the last one I have on my notes. So we can change it like an array. So what about removing things? If we try the pop one, and this will be important because every time I asked this to be printed, it came in the same order, right? Every time I said print, it always put name first, then age, then town, and fave food last. I could just keep printing this, and it's going to come in that same order every time. So it looks like there's an order, but there really isn't. There's some metadata that tell it what order it printed it in last time. That told it what order it created it in. So our pop with no indexing, well, I'll just run it because it does an error message. When we have a dictionary, pop needs an argument. We can't, just like we can say pop with no arguments passed in on a list, and that removes the last thing. It only looks like there's an order when it goes to print it out. That's metadata held in the background. There's not really an order to it. It's dynamic. It's changing on that. The stack heap diagrams I drew. The heap is dynamically allocated memory. It changes as needed. And these are dynamic structures when they get stored. So there's not an order to it. That's changing in the background, and there's just some extra stuff in the background keeping track of the order we created in it. So if we want to remove something, we have to pass in the index for it, which is that keyword. And I guess I can print this one, because unless I made a typo, that's not going to. That shouldn't throw an error. Okay, you can see the age and the value that age indexed or referred to is cleared out. So that data structure is really, really nice for organizing your code. You're probably going to want to mess around with that. And I think that was it. You have just all white space for scrolling on the little example I had. So let's see, it's 8:10, which leaves us a whole lot of lab time. which I wanted to go ahead and make sure there was lots and lots of lab time tonight to practice this. And just random practice using these. So you can go back to some of your programs you already wrote and update them to include lists or tuples or dictionaries and try that organization method. It can make your code look a lot nicer, have different benefits in different situations. So that employee example we started with, that would be a great one for a dictionary, right? Because then we put each employee in their own dictionary, and each one of those dictionaries has name, address, and rate of pay. I can't remember what the example was. Oh yeah, we can put nest them as well. I believe you all have seen nesting for nesting loops, nesting selection structures. We can make a list of lists. We can nest our list as well. All of these, I'll just do a list for an example. So a list made up of lists would have indexes inside of it. So like 1, 2, 3 is one list, and red, green, blue is another list, and they have square brackets nested inside of another thing with square brackets. So when we go to print that, we need both sets of square brackets. There's two notations that are commonly used amongst different programming languages. One of them involves one set of square brackets with comma separated value in it. What it really is we have a list of lists. So we need to like say, we want our first list, the second, third item in our first list. So that's what it really is, but that's so common that in some of the languages, they cleared out those middle ones because it's a little redundant. In Python, we do need the full brackets there. So the outer list, then the inner list, and two-dimensional gives us a table. So that one shows up a lot. I guess 3 dimensions you could think of as a table, like rows and columns from the first 2 sets of brackets. And for 3 dimensions, you could think of as like stacking things up on a table. Rows and columns to find your table and then make stacks in those tables. And we can continue that beyond 3 dimensions. It just gets hard to visualize and come up with analogies for when it gets very far along. But it should seem fairly intuitive, having seen nested stuff in other places. Just a list inside of a list. And tables are very useful, so rows and columns, which if you do it as a dictionary, you can actually use row and column as your index. And to help keep your code nice and organized, and easier to make sense of. So we can see the second element in our first list that way. The first element is an entire list, so then we have more indexing inside that. Or we can think of it as row 1, column 1, 2, 3 in the first row, and row 2, column 1, 2, and 3 in the second row. Hopefully that one comes along intuitively. All the same methods we have still apply. So if you want to append or extend something, if extend does an entire list at a time, append does one element at a time, so you want to make sure and be careful whether you're appending to the first set of indexing or the second one. The first set of square brackets or the second one. It's kind of the only thing to watch for there. Otherwise, hopefully it should seem fairly intuitive. Does anybody have any questions? I see head shaking no in here. Video's okay. I'll give it a couple seconds.
No questions here.
Okay, so that's the quick pass on syntax of this. I'll add some comments to this and get this sent out. Looks like we still have an hour and a half on our scheduled time. But I want to make sure there's plenty of lab time tonight, so maybe good random practice without the frustrations that come along with those homework assignments from the textbook. As y'all know how computer grading things are. It's probably not gonna like something you type in there and take a few passes. But some good random practice will be some programs that you've already done. Change those over to lists and tuples and dictionaries, and get used to the structure of it. And remember that analogy we started with. It's hard to see the benefit at an introduction level, not just in here, the coding boot camps, every introduction class. So think about the backpack. Instead of carrying a stack of data, we're going to put our data in this nice organized thing, and anytime we need it, we can just loop through it. Oh, we didn't see a loop, did we? I guess we should probably see that somewhere up here. We've seen for loops. I'll put it at the bottom, that way I don't lose track of it. So for is actually a for each. So then we need a reference name for each element. That's what we're going to call it when we look at stuff. For each element in my list, I'll go back to the beginning, but this would work for all of them. Just print it out, I guess, right now. Element. Probably in your programs, you want to do something more interesting than print it, but I'm just going over the syntax because it's an active subject. Quickly going over the syntax so there's time to do this stuff, because you'll learn a whole lot more by just doing it, get used to it. And you can see that just loop through the for loop. We didn't need any sort of reference to indexes or anything. You just walk through there, and that's what the word countable means. Doesn't necessarily mean we have those numerical indexes. It means there is definitely a start and definitely an end to it. So we could count the stuff if we want to, but we don't need to. We can just, the computer can find the start and the end and everything in between. And that's the idea on a for loop there. So I'll add some comments and send this out, but as always, I will be here ready to answer questions till 9:50. If everybody leaves, I'm pretty sure we're the last class on campus. So it'll just be me and the security guard, so I'll probably head back to Clarksville if everybody leaves. Otherwise, text messages and how we learn messages make noise on my phone. This is the time that I know I will be sitting here ready to answer questions. Might be a 10-minute gap while I drive home. And that is not restricted to this class. You can ask me questions at any time. Sometimes it might take a while. And just yesterday, I was exchanging text messages with a former student who just got a new job and wants to make sure he's on that. He graduated a couple of years ago. Another group of former students started a programming firm, and they periodically contact me. We call it consulting work. Since I started the business, we'll call it consulting work and include a paycheck for it now. But I am always happy to answer questions. Doesn't have to be this classroom. 3 years from now, if you get stuck on a coding problem and you think I might be able to help with it, I'll still be happy to answer a question. Otherwise, you all have a good evening. I will see you on Wednesday.
Thank you. Good night.
Oh, I have to stop the screen sharing.
Bye.
Bye.
Thank you, sir.
Have a good one.